We're always trying to figure out why things happen, from why a stock market crashes to how a new idea suddenly goes viral. But what if we could teach an AI to read, well, everything written about a topic, and then actually draw us a map of every single cause and effect link? That's exactly the incredible new technology we're looking at today.
And look, this quest to understand why is not new. I mean, we're talking ancient history. The Greek philosopher Democritus, and you're going to want to remember that name. He said that finding just one true cause was worth more than an entire kingdom. That really sets the stage, right? It shows you how hard and how valuable this whole endeavor really is.
So to see how this new tech actually works in the real world, we're going to tackle a huge 5,000-year-old cold case, the mysterious decline of the Indus Valley civilization. I mean, this was one of the world's first great urban societies, and it just faded away. It's the perfect test for mapping out chaos.
Now, when we ask a question like this, we're kind of hoping for a simple answer, aren't we? A big invasion, a catastrophic flood, maybe a plague. But the truth, especially for these massive historical shifts, is almost never that easy. It's more like a puzzle with thousands of scattered pieces. And when you look at the evidence, scientists have pieced together this incredibly complex picture. It wasn't one single event, but this whole cascade of interconnected problems. We're talking about decades-long droughts, which meant less monsoon rain, that changed the course of the rivers, which then totally crippled their trade networks, and all of this led to a slow, gradual move away from the cities, not some sudden collapse. Trying to map how each of these things fed into the next is just a monumental task for a human brain.
So how in the world can we possibly make sense of this tangled web? Well, this is where a new AI system, named after our old friend Democritus, steps in. Meet Democritus. It's designed to be a completely new kind of map maker, but not for land, for causality itself.
The core idea behind it is just so powerful and, honestly, pretty simple. What if you could just tell a powerful AI, hey, go read the hundreds, maybe thousands, of scientific papers, articles, and books about the Indus Valley, and then connect all the dots for us? I mean, literally draw us a map showing how everything is connected to everything else.
And that's exactly what Democritus is. It's a system that uses a large language model. Yep, the same kind of technology that powers tools like ChatGPT to act as this incredible discovery engine. It goes out and finds millions of tiny, isolated claims of cause and effect that are scattered across all these different texts, and then it weaves them all together into one single, structured, visual map.
Okay, so how does it actually do that? I mean, how does it turn all of that messy human language into a clean, structured network that we can actually understand? Let's break down the process.
It really boils down to a three-step process. First, the AI acts like a tireless expert researcher, just brainstorming all the key topics and questions about a domain. Then, it dives into the text and starts pulling out thousands of simple causal statements, things like X causes Y. Finally, and this is the crucial part, it links all of those individual statements together into one giant graph, a massive network of knowledge.
The way it makes this concrete is by breaking down sentences into these basic building blocks called causal triples. It's just a simple structure. You have a cause, a relationship, and an effect. So you get things like reduced rainfall decreases Indus River discharge. And as you can see, when you start linking these simple little triples together, they form a chain of logic that starts to tell the whole story. Now, this all sounds fantastic in theory, but here's where the story takes a twist. When the system first connects these thousands upon thousands of little causal links, well, the result isn't exactly the beautiful, clear map you might be picturing. Instead, you get what the researchers call the giant hairball problem. The first thing it spits out is just a chaotic, tangled mess. Seriously, just imagine a subway map where every single station is connected to every other station. Sure, it's technically accurate, but it's completely useless. It actually creates more confusion, not clarity. And honestly, this could have been a total dead end for the whole project.
So what do you do with that? How do you take this giant, messy hairball of data and find the elegant, hidden structure that you just know has to be buried in there somewhere? This was the absolute central challenge the creators of Democritus had to overcome.
And they solved it. They did it by inventing a totally new AI method, a kind of, well, let's call it the secret sauce, that can see patterns that other algorithms just can't.
This secret sauce is called a geometric transformer. And here's a way to think about it. A normal algorithm just sees direct connections, right? A causes B. But the geometric transformer sees higher-level patterns. It can spot things like long chains of influence,
where A causes B, which causes C, which causes D, and even more complex shapes like triangles of influence. It's literally looking for the hidden geometry inside the network.
And this, right here, is the aha moment. The geometric transformer acts like this incredibly powerful focusing lens. You point it at that giant, messy hairball of data, and bam! Everything just snaps into focus. The chaos organizes itself into a coherent, structured, and, I gotta say, even beautiful map of cause and effect.
So we've got this amazing new map-making tool. What can it actually show us that we couldn't see before? What new insights can we get by looking at the world through this new kind of lens?
One of the coolest things is its ability to zoom in and out. Think of it like Google Maps for ideas. You can zoom way in for a local, street-level view and see all the immediate causes and effects around a single topic, like the minimum wage. But then you can zoom all the way out to this global satellite view of the entire field of economics and see how all the big concepts cluster together and influence one another.
And by looking at that big global map, you can instantly spot what they call the causal hubs. These are the heavy hitters, the concepts that have this huge, outsized influence across the entire system. And it's fascinating. In their analyses, things like personal stress, economic inflation, and even new technologies like generative AI popped up as these central nodes, with connections branching out all over the place. It tells you what the real drivers of change are.
Okay, now it is super important to be clear about the limitations here. This system creates an incredible map, but it's a map. It is not the absolute truth. It's building on the knowledge and any potential biases that are already baked into the large language model's training data. It generates these brilliant, structured hypotheses for us to go test, but it does not replace real-world experiments or validation from human experts. You should think of it as the world's best research assistant, not as an all-knowing oracle.
And that really brings us to a final, pretty mind-blowing thought. If a tool like this can bring new clarity to a mystery that's 5,000 years old, just imagine the modern complexities we could start to map out. We're talking about things like climate change, global financial crises, or the societal impacts of AI. What hidden structures might we finally be able to see in the chaos that surrounds us every single day?